put heat in. I take heat out, right? I put my water in the freezer. If I'm taking heat out, is that an exothermic process or an endothermic process? Exothermic. Does exothermic have a negative sign or a positive sign? Negative. So delta H crystallization is negative. Fusion, to melt something, I have to put heat in. Positive. Right, again, I'm showing you the logic of how to learn this and not just memorize it. If you can walk through those steps, you'll retain it a lot better than just blunt force, negative, positive. Deposition, sublimation, we have their opposite processes, so we can do the same thing. Delta H deposition is the negative of delta H sublimation. In deposition, I'm going from a gas to a solid. So I'm taking energy out. From a solid to a gas, I'm putting energy in. However, there is one more thing that we can take away from this. Let's focus on sublimation. So sublimation, we just said, and I'll rewrite it just so we can focus on it. Sublimation is going from a solid to a gas. And that has the value of delta H sublimation. The interesting thing about enthalpy, let's move this up now. Remember our terms, H is enthalpy, which also means heat. So if I'm going from a solid to a gas, for today, that is the same thing as going from a solid to a liquid to a gas. So delta H sublimation is equal to solid to a liquid is fusion, liquid to a gas is vaporization. Delta H sublimation is equal to the value of delta H fusion plus delta H vaporization. So enthalpy, it does not matter if you go from a solid to a gas or from a solid to a liquid to a gas. If you just look at the phase changes, it's the same energy. So this is saying the same energy needed for those two pathways. We see that a lot when it comes to, and honestly, we're in physics right now, but in the idea of physics and chemistry, this idea of two pathways having the same energy, that happens a lot, right? So for sublimation, that is equal to the energy needed for fusion and vaporization. Right, so any questions about that information there or that idea there? So to sublime something, it's the same energy as to melt it and then boil. So to deposit something, a deposition, I'm going from a gas to a solid. If I'm going from a gas to a solid, it's the same thing as going from a gas to a liquid to a solid. Each of those processes, I need to remove energy. So yeah, it would be exothermic. The way I also remember that, gases are high energy, solids are low energy. So if I'm going from high energy to low, I have to remove that energy. All right, I know it's a long day. My throat's feeling it. I can't imagine your heads are feeling much better. But we're going to end today with one more question. One of these fun critical thinking questions. Yay. See how well we understand this. So, question. The heat of vaporization of water is 40.7 kilojoules per mole. The heat of fusion of water is 6.07 kilojoules per mole. Yep. My question to you, why is the heat of vaporization so much bigger than the heat than delta H fusion, the heat of fusion? And this is true of any substance you look at. It takes more energy to boil something than it does to melt something. What I want you to do, those of you following along at home, playing our home version, you can put this in chat if you have an idea too. I want everybody to think about why this is. And if you have an idea, feel free to share it amongst each other. Feel free to have group discussions on this. See if you can put everything we talked about this week and give me an answer to this. So I'll give you a couple minutes to think here. And again, feel free to discuss as much as you like.
Yeah, so it's like, yeah, you're really like racial. It's like meeting that. What's something to that? So you're like raising.
All right, so looks like everybody had some time to think, and since the Zoom people don't have the opportunity to chat amongst each other, I could force you into breakout rooms, but let's be honest, in breakout rooms, they generally don't work even amongst faculty. So let's read what we have up there. And sorry, I'm going to put everybody on the spot. Thank you for typing in, though. I appreciate it. It takes more energy to break bonds than to fuse bonds. Terminology there. So fusion, it's not how you'd use it in English, right? When you fuse something in English, you combine it. Fusion in this term means to melt. So you actually are breaking bonds here. So in both cases, you break bonds. Converting liquid to a gas takes more energy than going from a solid to a liquid. That's true. So the question is why? That's what I'm looking for there. And then we have, I think heat of fusion is smaller because in order to overcome the intermolecular forces, you don't need much energy at that stage. But to boil, you have to completely break bonds to form a gas. So that's the answer. So going from a solid to a liquid, you don't break many intermolecular forces. You break some, but only a small amount. Going from a liquid to a gas, you break them all. So I'll just write that down. So going from a solid to a liquid, you break few IMFs because you're still together as a group in my soda. You're still interacting. From a liquid to a gas, you break them all. You break all IMFs. And so that's why we see vaporization so much more energy. You have to put more energy in to break more bonds. Questions about that idea? So it's tying back to our main point again of IMFs. All right. So just a few reminders for you. Pearson. So based on what we talked about today, I will put a homework up. That's due next Thursday. So you'll see a new assignment go up today. Remember, you have one due on Tuesday from our previous session. Now, we still have more slides to go over that I had planned for today. So on Tuesday, you will have a new pre-class assignment. But the PowerPoint will probably be a little shorter than it was. Well, it will be shorter than it was for today. Thursday, that will also be true. So what I'm going to do when I go back to my office, I'm going to make these new folders. I'm going to put up the homework. You should see those this afternoon. If you have any questions about anything we've talked about or anything about the class, feel free to email me. I will be on campus today for a little bit, so you can stop by. Otherwise, we can meet over Zoom if you want to. Otherwise, I hope everyone has a good rest of your week. And hopefully I'll see you folks on Tuesday. Have a good one, my Zoomers.